Next video deals with the matching questions, 6 through 10. I don't know how many of them I'll get through, but if this goes on too long, I'll stop it and make a fourth video. Okay, so question 6 is a rational function. That means that it's probably going to have some asymptotes. And we're first asked where the vertical asymptotes are. And vertical asymptotes are found at the zeros of the denominator. Well, we can see that -2 and +3, each of those will make this denominator 0. And so we have a vertical asymptote at x equals -2 and a vertical asymptote at x equals +3. Now we're asked for one more identifying characteristic of the function that helps us choose our matching graph. And we see that since the degree of the numerator and the degree of the denominator are the same, we'll have a horizontal asymptote. We will find that by dividing the leading coefficient of 1 in the numerator by the leading coefficient of 1 in the denominator. 1 divided by 1 is 1, so we have a horizontal asymptote at y equals 1. Now that's enough because we're only asked for one more characteristic. But if we didn't spot that, we might notice that there are x-intercepts at -1 and 2, because x-intercepts are going to occur where the numerator is 0, because that will make the entire function value 0. So we see that -1 and +2 each make the numerator 0. So we have zeros, or x-intercepts, at x equals -1 and x equals +2. Finally, we can find the y-intercept because the y-intercept is going to occur where x is 0. Well, when x is 0, these terms, x squared minus x, those vanish, those are gone. So we have this is 0 and this is 0. X squared minus x is 0 in both numerator and denominator, and that leaves -2 over -6, which simplifies as +1/3. So we have a y-intercept of xy is equal to 0 1/3, or we could say we have a y-intercept at y equals 1/3. Now, which graph does this match? Well, first of all, A, B, D, and E are not going to be matching graphs because they're not rational. They're not rational function graphs. They're polynomials. So we look at the rationals, which means graph C and graph F. And graph F is the one that has a vertical asymptote at -2 and +3. So graph F is our matching graph. We also see the horizontal asymptote is at 1, and zeros are at -1 and 2, and the y-intercept is at 1/3. So all of those things tell us that F is our matching graph, and I've indicated that here. Now, for question 7, we're asked to identify the zeros. We can see, since our function is presented in both expanded and factored form, we can see that we have a 0 at -3, because -3 plus 3 is 0. That makes the whole function value 0. And its multiplicity, we see right here, is 1, because no value is indicated here. That means that it's only present one time, so the multiplicity there is 1. We also have a 0, and this is a tricky one, an easy one to miss. we have a 0 at x equals 0, because if we have a 0 here, 0 squared is 0. That again makes the entire expression, the entire function value 0. And its multiplicity is 2. So that means that the graph is going to bounce at x equals 0, y equals 0, which is the origin. So the graph is going to bounce at that point. Excuse me. Now, we also have a 0 at positive 5, because 5 minus 5 is 0, and its multiplicity is 1. And then we are asked for, again, another characteristic that would help us to determine the choice of matching graph. Well, this graph, or this function, has a negative leading coefficient. Be careful and look out for that, because it's not that easy to see in print on the paper. This has a negative leading coefficient, and the degree is even. So that means that it's going to point down at both ends. And the last characteristic I spotted was the y-intercept. Well, the y-intercept again occurs when x is 0, and when x is 0, this term vanishes, that term vanishes, and our function value is 0. So we have a y-intercept at the origin, xy is equal to 0, 0, or we could say we have a y-intercept at y equals 0. Now that we have that information, we're ready to match this function to the appropriate graph. And so we take a look at our graphs. We know that we're going to have that this is going to be a polynomial. So that means that graph C and graph F are not the appropriate choices. And we also know that with a leading coefficient, a negative leading coefficient, and an even degree, that it'll point down at both ends. And the only graph that does that is graph D. We know that the 0 at 0 bounces, and we know the 0 at negative 3 and positive 5 slices through, because the because the multiplicity is 1. So our appropriate graph, the correct graph, is graph D. So that's our choice. Now, let's see, we see that here. Now, moving to question 8, we see that it is a rational. And we could just about say, well, graph C is the only other rational left, so let's choose that. But let's make sure. We're asked for, especially since the question requires us to give the vertical asymptotes and one more characteristic. Well, the practice that I distributed did not have the denominator factored, but it's the difference of two squares, and that's the easiest factorization, just about the easiest factorization we could have. And so that's shown here. X squared minus 1 factors as x plus 1 times x minus 1. And that gives us vertical asymptotes at x is negative 1 and x is positive 1, because those are the two values that make the denominator 0. What other characteristics do we have? Well, this graph has a slant or oblique asymptote, because the degree of the numerator, 3, is exactly 1 greater than the degree of the denominator, that is 2. So we have a slant asymptote in this graph. And we have a y-intercept of 0. We have a y-intercept at y equals 0, because when x is 0, the numerator is 0. That makes the whole function value 0, and so that's our y-intercept. And so now turning to our graph, sure enough, we can see that the y-intercept is at 0. And our vertical asymptotes are -1 and +1. And we have a slant asymptote because the graph appears to not want to touch a slanted line that we can imagine running through here. So our choice of graph is C.